Hello. Today we're going to be setting up the Catch2 template for use with CLion for your project in DSA. So we're going to use project 1 as an example here, but this method will also work for project 2. The template is fundamentally the same. There's just a little bit different starter code and starter tests that we provide. So first what you're going to want to do is go onto the project document and scroll until you find the starter template. So you'll see in the helpful resources, it's linked, well, not in the catch testing tab, but it's in the starter template tab. So what we originally provided was this old project1.zip template, and you can still use that if you want, but it makes it a little less seamless. For instance, when you want to do your catch test, you're gonna have to comment out your entire main file, and that's really annoying. So instead of that, we have a new updated template which uses some CMake trickery to make it so that you can have your main and your tests run at the same time, and also just provides a lot of conveniences so you don't need to set anything up, and it should work in your environment regardless. So what you're going to want to do is click on this updated template link. It'll take you to a GitHub repository, and this GitHub repository is called a template repository. And basically what that means is you can take the template repository, copy it, and then have your own version of it. So if you're interested in setting up VS Code, you're going to want to click on this video. This talks about code spaces, which is just remote VS Code. And also you can use this workflow if you wanted to download the template locally and use that instead. But we are going to be discussing method 2, which is local development with CLion. So let's get started. First off, you're going to want to make a copy of the template repository in the same way that you would for the code space. It's always good practice to keep a Git repository for your projects. You just got to make sure it's private so you don't leak any of your code and potentially do an academic dishonesty. So to do that, we come to this big green use this template button, click it, and we say create a new repository. And now this is going to open the repository creation menu. You don't really need to include all branches. The main should have everything you need. You want to put it under your user. If you have an organization, I guess you could do that, but generally just your user, and you can call it CLion P1, can't type, sorry. CLion P1 demo, great. Add a description if you want, and most importantly, make sure that it's private. If it's public and people can see your code, they could try to steal your code, and that would be no good, because then it might get flagged for copying code. So we'll create our repository, and it'll take a couple moments. It'll do a funny little loading screen, and then, boom, we now have our own brand new, fresh repository, which we can use to do our coding. So it's all the same. You can use the documentation off this if you want. And now let's get it into CLion. So here I'm at the CLion kind of starter area. You can get to this if you have an open project by clicking the tab and saying close project. Excuse the neighbors. We have all of my projects here, and we want to open this project. So there's a couple ways you could do this. For one, you could just download the zip file, and then it'll go into your downloads. You can choose to extract it somewhere. I'm going to extract this to, downloads, why not? So this will go to my downloads. I'll show the files. And so when you open it in CLion, you're going to want to make sure, not new project. You're going to want to make sure you don't open the folder that it's in. Like for instance, since it's in my, since it's in my downloads folder, you don't want to open downloads as the project folder. You want to open CLion P1 demo main. And so you can open it like this, say, okay, you're going to want to trust the project. I promise we didn't put viruses on it. Feel free to audit it if you're worried, and it'll say trust project. So it should open up here, and you'll see you want to enable the default debug profile. You can leave everything as it is and then say okay. And so now it's going to be loading the CMake project. One thing to note is, it's too late. So in the CMake list.txt, we have these 3 lines at the bottom for include ctest, include catch, and catch discover test tests. And these are to make it so that VS Code can discover all of the catch tests you write. This is unnecessary on CLion. CLion already hooks into catch directly. And so these lines end up giving you these extra targets, but you can kind of just ignore them. All you really need to worry about is main up here and tests. That's for testing your catch tests. So as you can see, I'm just going to run the test, and we'll click the play button. It goes, and then the first time it is going to build, catch because it pulled in the source code using Git, and now it's on your computer. So make sure you have Git. And we can see we have our tests. Some of them passed, some of them didn't. If we look at our test.cpp, we'll see oh, this one didn't pass, this one did, and that is how that works. Now, one other option, I think it's a little more convenient than downloading and navigating the folder. What you can do is click either the version control tab, or sorry, wrong tab. But let's say we're back at the main menu. I'm going to close this project. You can say get from VCS, and now all you have to do is, now all you have to do is just straight up paste in your GitHub URL into the little dialog box. Or if you have your GitHub hooked up, you can scroll through your repositories there, say clone, and you'll have to log in via GitHub. It'll open up here. You can say authorize. You can say authorize. And then it connects your CLion to your GitHub, and then now you can pull in the project and commit to it as normal. So once you say trust project again, it opens up. Again, leave the defaults. If you're quick enough, you can go into cmakelist.txt and remove these lines so it doesn't give the extra tests. And save it. Might have been too late. Yeah, we still have all these things. So if you're really worried before opening it, you can delete those lines, but it shouldn't really affect the functioning otherwise. I will close these windows. And so yeah, now we are in our code. So let's take a little bit of a tour around the code base. Our source folder holds all the main code. So we're going to see our main.cpp. Right now we just have a very simple hello AVL. And to run it, we're going to want to make sure we're in the main executable, and we'll hit play, and it'll build our code and print it out. And say if we wanted to change something, very simple, you can just, I don't know, type more words. Let's say hello AVL, goodbye AVL, exclamation point, and I'll throw a new line at it so it doesn't look bad. Say play, there it goes. Now let's say you want to add a header file. That's really simple. In the source folder, you can right click and say new, and CLion's really nice in that it'll let you just make a new C++ class and it'll autofill a bunch of stuff. So let's say I want all of our code to live in avl.h, right? So, or I'll just call it avl, and then it'll make the avl.cpp and avl.h file. It's not going to be in a namespace. If you wanted a header only, you could make a header only. And then it's also going to ask you if you want to add to targets. And so you're going to want to add to main and tests. So let's show a bit about what this is doing. So down here, we can see it's a little window into our cmakelist.txt. And what that means is basically there's the add executable blocks are what tells CMake what files to compile with your code. And so in this add executable block for main, right now it just builds main.cpp. But by saying add to targets main, it's also going to add our avl.cpp and our avl.h, so it gets built. And you can see it shows you how that works. And then we also want to add to tests because probably we're going to want to be able to access our avl.cpp and avl.h from tests. So we can say, okay, it's going to add it. And ideally, you're going to be adding all of your files to Git. And we can talk a bit about how to use the Git commands later. You can see right here is the commit window. We'll talk about that in a second. And yeah, so now we have our AVL class and avl.h, and we have our AVL implementation code. So let's just define a simple little function. Let's say it's going to be void. We'll call it print tree. It's not going to take any inputs, and that's it, because this is just a definition. A really useful feature of CLion is what you can do is right click here, and it'll pull up a menu. And what you can say, there's this little generate button. So you can click generate, and you can tell it to, generate definitions. And so what this will do, you click this, Control-Shift-D, if you want to use the command, it'll go into, it'll let you pick the functions, and then you can say okay, and now it'll just fill this out in your avl.cpp, and you could use this for multiple files. So it's very useful in that regard. So let's say, what do I want to say? I want to cout. Oh, we actually need to include that first. IOStream. Oh, hold on. I did a bad command there. I don't know what that's doing right there. Okay, sorry about that. We have our IOStream. And so now we, I'm just gonna use namespace standard. Feel free to use the feel free to either pick and choose individual files or just put standard in front of everything, but I prefer using namespace standard for project file or for school projects. So we'll say cout, I don't know. Let's assume that we're printing out a pre-order traversal of a tree or something. We can throw our endl on there, finish the line. save our file, but which should happen automatically. And now from our main.cpp, we can include our magical header. So we'll say include avl.h, boom. And now let us reference this function. Let's say we want to reference avl. Oh, wait, sorry, my bad. So we want to make a avl tree is equal to, and then we want to say tree dot print tree. And so now it'll print out our tree. Why is it mad? Oh, it's private. Forgot to make it public. Okay, so that is also my bad. We will put the public namespace here. Boom. Okay, so now it is public. Why is it mad? Oh, sorry, this is the CPP file. I'm forgetting all my C++ knowledge. Okay, my bad. We will make this function public. There we go. And so now we can save the file. It's nice and formatted. Now, when we come to here, we'll be able to run either just the main by itself or run the entire main executable. Hit play. It'll say hello AVL, goodbye AVL, and then it'll print out our preorder traversal. And so that's all you have to do. So let's say we want to do some testing instead. What we'll do is we'll open our project folder and we will come to this test folder and we will see test.cpp. Catch, you don't need to worry about this. This is if you're using method 3 command line testing. So open test.cpp and here you can see our big test.cpp file. I'm gonna make this smaller. And so this shows all of our test cases. So we have a number of cases. Let's see. So our first one is an example test. We defined 1 as 1. And to make this test case pass, all of the required statements need to evaluate to true. So right now, 1 is equal to 1. This is not going to evaluate true. So let's just replace this with a 1. Now this individual line should be true. But you'll see if we run the test, it's going to build the test, or it needs to build catch first. Okay, catch is built, and you'll see that the test failed. Why did it fail? Well, it seems we required false, but it got false. And basically, anything you put in these parentheses, if it evaluates the true, the required statement is going to pass. If it evaluates the false, it's not going to. So we can just replace this with the word true. Oops. We'll save that. And now, if we run our test again, we'll see that it passes. And so that's all you really need to do. This is the main workflow. Anything you need to test, you can include in here. So let's say I want to include, oops, my bad. I want to include avl.h in here and test one of the AVL functions. We can make a new test case. I'll call this test case. Then you want to give it the name. I'll say print tree. And then it doesn't need any flags, but I'll call it example. You can organize your tests with tags and then test only those later. We'll go in here and we will say require, well, you can't really test a cout, which is one thing to keep in mind. There's ways around it, but it's not really intended. So let's make print tree return a Boolean instead, and then let's make it return true when it's done so we can test it. And this is one thing you want to keep in mind as you write your code. You want to make sure the functions that you write are testable, otherwise you will run into some errors. So let's say return true. Now our function is happy. We also need to change this in the AVL. And then we'll change this to bool. We can save, and now when we come back to test.cpp, we can say require, oh, we got to instantiate our AVL, and we'll require that tree.printTree evaluates it true. And we could say equal true, but this is logically the same thing. So we can run our test, or let's run all our tests. We'll see. It's going to run them. Oh, it just ran the example test. You have to click up here, select your configurations, select tests. Then you can run. It'll choose all of the tests, and we'll see that they all pass now. This one we made, print tree, and these other ones. So this should be all you really need to know for working with CLion. And remember, if you forget to add to targets, any new headers you make are going to need to be added to these add executable blocks, so CMake will see it. And with that being said, if you have any questions, please first make sure to look at the common issues section at the bottom of this document. There's all sorts of things that have gone wrong in past semesters and all sorts of solutions here. It could help to Command F. You could say like, I don't know, void, And then you can see, oh, how do I test a function that returns void, or how do I test a function that's private? There's tips for that all in here. And with that being said, thank you so much for watching. I hope you do a great job on your project 1. And if you can't solve your issue with the common issues section, please reach out to any of us TAs in the Discord. All right, have a good one. Thank you.